Geometric mean. The geometric mean of two positive numbers a and b is the value of x in the following proportion. A over x equals x over b. You cross multiply and you will get a times b equals x squared. So x equals the square root of a times b. Now, in our problem, we have to find the geometric mean of 2 and 24. So let's call 2a and 24b. So we have 2 over x equals x over 24. Cross multiply, 48 equals x squared. Find the square root. These cancel, leaving x equals the square root of 48, or we can simplify this and say the square root of 16 multiplied by the square root of 3. The square root of 16 is 4. 4 times the square root of 3 equals x. Now, how to apply that? The application of the geometric mean. The geometric mean theorem, or the altitude, which is the height of a triangle, in a right triangle. Now that's the important part. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So we're looking at the altitude from the right angle to the hypotenuse. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. So, if we have a triangle A, B, C, this is our right angle, we're going to find the geometric mean, which is we take our line straight down, making a right angle here on the hypotenuse. So we have we're going to call this one D. We have CD squared equals AD times DB. So, in this equation, CD squared is x squared equals AD is our A and DB is B. Now, let's look at the next part. The geometric mean leg theorem, see, in the top part we're looking for altitude, and the second part we're looking for the leg. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse in two segments. We just got through saying that, but here's how to use it. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Remember, adjacent means next to. So we have AC equals AB times AD, and AC is squared. We also have CB squared equals AB multiplied by DB. And that's when these are labeled exactly the same as we did above.